Now, in this lecture, we'll answer on two questions. In the first question, we'll find out the radius of this quarter circle. In the second question, we'll find out the size of this angle, angle theta, that is inside triangle ABC. So we'll start with the first question. In the drawing, we have a quarter circle. We know that side BC equals to 9 units, side CD equals to 6 units, side CD equals to 16 units, and side DL equals to 12 units. Angle OBC, this angle equals to 90 degrees. Angle BCO also equals to 90 degrees, and this angle CDL equals to 90 degrees. And our mission is to find out the radius of this quarter circle. So, because of the fact that this is a quarter circle, then it means that this point O is the center of the quarter circle. Okay, so I write it down that point O is the center of the quarter circle. And angle BOF, this angle is equal to 90 degrees. It is a right angle. It is true in any quarter circle. And the third thing that we can conclude from the fact that this is a quarter circle is that here, side AO, this side AO is equal to side OF, to this side OF, and both sides, they are the radii of this quarter circle, the radius that we are looking for. So we'll define the radius of this quarter circle as capital R. So here, AO is the radius of the quarter circle that is equal to capital R, and OF, it is also the radius of this quarter circle, so it will be also equal to capital R according to our definition. So in the next step, we will extend line segment CD by a straight line until it touches the radius of the circle OF. Okay. And we will define the touching point of the extended line segment CD and the radius OF as point M. And here we created, by this construction, we created a quadrilateral BCOM. Inside quadrilateral BCOM, we have 1, 2, 3 right angles. So, write it down. Inside quadrilateral BCOM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually this angle, angle DMO. In total, the sum of those all 4 angles, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we subtract 270 degrees from this equation, and we get that according to this equation, the missing angle DMO is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So we actually found out that the missing angle, it is a right angle. This angle equals to 90 degrees, it is a right angle. So actually we found out that inside quadrilateral BCOM, this quadrilateral, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral BCOM as a rectangle. Why? Because it has 4 right angles. Quadrilateral BCOM is a rectangle. Okay, but we also know that the opposite sides of a rectangle are equal to each other. So actually here, the opposite sides of rectangle BCOM must be equal to each other. That is to say, side BC must be equal to side OM. Side BC must be equal to side OM. According to the rule that the opposite sides of a rectangle are equal to each other, side BC must be equal to side OM. Here it is given us the equation that side BC equals to 9 units, so BC equals to 9 units. And from this equation, 9 equals to BC equals to OM, we will derive that side OM is also equals to 9 units. OM equals to 9 units, so we can write here that OM equals to 9 units. As I've already mentioned, here side OF is the radius of the quarter circle, the radius that we are looking for. So OF is the radius of the quarter circle, it is absolutely a straight line. Okay, so write down that this side OF, is defined as the radius of the quarter circle, therefore it is a straight line. OF is a straight line. And we actually have here rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if CD is a straight line, then if we focus on the upper side of the straight line, CD at point O, here the sum of the angles here must be equal to 180 degrees, that is to say angle alpha plus beta, they must be equal to 180 degrees. So we can implement rule number 3 in our drawing. Why? Because in our drawing we have the straight line OF, and if we focus on the upper side of the straight line OF at point M, then the sum of the angles on the upper side of the straight line OF at point M, they must be equal to 180 degrees. So which angles we have at the upper side of the straight line OF at point M? We have here 90 degrees, and we have also angle DMF. 90 degrees plus angle DMF in total they must be equal to 180 degrees. So here we subtract 90 degrees from this equation and we get that the missing angle DMF equals to 180 degrees minus 90 degrees, it is equal to 90 degrees. So we found out that the missing angle DMF equals to 90 degrees. This is a right angle. Likewise, it is given us the question that line segment CD that is equal to 16 units, it is a straight line. Then we extended the straight line CD by a straight line. The result, that is CM, must be also a straight line. I'll repeat again, we extended the straight line CD by a straight line and we got CM. When you extend the straight line by a straight line, the result must be a straight line. So the result, that is CM, must be a straight line. So I'll write it down. So line segment CM is a straight line. Line segment CM is a straight line. So if we focus on this side of the straight line CM at point D, then the sum of the angles on this side of the straight line CD at point D must be equal to 180 degrees. Okay, so which angles we have at this side of the straight line CM at point D? We have here 90 degrees. Plus this angle, that is actually angle LDM, plus angle LDM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So here we subtract 90 degrees from this equation and we get that the missing angle LDM equals to 180 degrees minus 90 degrees, it is 90 degrees. So I found out that this angle equals to 90 degrees, angle LDM equals to 90 degrees, it is a right angle. So inside quadrilateral, before that actually, here we have two right angles. So in the next step we will do a construction from point L. We will draw perpendicular on the radius OF. I'll repeat again, from point L we will draw perpendicular on the radius OF. Okay. So actually this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point L and the radius OF as point N. Point N is the touching point of the perpendicular from point L and OF. As you can see in the drawing, line segment OM, this line segment ON is shorter than the radius OF. Therefore, ON, the length of ON is not the radius of the quarter circle because the radius of the quarter circle is a little bit longer than ON. Okay, so here we created quadrilateral or DLMN. Inside quadrilateral DLMN, we have 1, 2, 3 right angles. I repeat again, inside quadrilateral DLMN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle DLN. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral must be equal to 360 degrees. This expression expresses the fact that the sum of the angles in quadrilateral DLMN equals to 360 degrees. Okay, so here we subtract 270 degrees from this equation and we'll get that the missing angle, angle DLN, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees, that is to say it is a right angle. So we found out that this angle, angle DLN, it is a right angle, it is equal to 90 degrees. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to quadrilateral DLMN as a rectangle. Quadrilateral DLMN is a rectangle. Why? Because it has 4 right angles. Okay. Quadrilateral DLMN is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DLMN, they are equal to each other. So here we know that in rectangle DLMN, side DL must be equal to side MN. DL must be equal to MN. Okay, again, in rectangle DLMN, side DL must be equal to side MN according to the rule that the opposite sides of a rectangle are equal to each other. But according to what is given as the question, side DL equals to 12 units. So we can write here that DL equals to 12 units. And from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Side MN equals to 12 units. As I already mentioned before, here ON, line segment ON, that is equal to 9 plus 12, that is 21, it is shorter than the radius OF. Therefore, we can conclude from it that the length of the radius OF will be a little bit greater than 21 units. Okay? You can see here that point N is very close to point F. Therefore, the difference between ON and the radius OF will be very, very small. Okay? So we expect that the radius of this quarter circle will be a little bit greater than 21 units. Because ON equals to 21 and OF, that is the radius, it is a little bit longer than ON. Okay? So here, so we can write down that ON equals to 9 plus 12, that is 21 units. The length of ON is 21 units. So in the next step, we will define side DM as H. Here, side DM equals to H according to our definition. I write it down. Side DM of the rectangle DLMN equals to H units according to our definition. But according to the rule that the opposite sides of a rectangle are equal to each other, we will get that side DL equals to side LN. Side DL equals to side LN according to the rule that the opposite sides of a rectangle are equal to each other. Actually, it is side DM. It is actually side DM. I'll repeat again. Side DM, this side, equals to side LN according to the rule that the opposite sides of a rectangle are equal to each other. Okay, but according to our definition, so DL equals to LN, but according to our definition, side dm equals to h. So we can write down that dm equals to h, and from this equation h equals to dm equals to ln, we will derive that side ln is also equals to h. Okay? Side ln is also equals to h. So I can write down here that side ln equals to h. Okay? In the next step, we will join points O and C together by a straight line. By joining points O and C by a straight line, we created here the right triangle OMC, the right green triangle OMC. But what is the definition of line segment OC? It is the hypotenuse of the right triangle OMC. It is one thing, but line segment OC, it is also another thing. You know that point O is the center of the quarter circle. Point C is the point of the quarter circle itself. Therefore, OC is the radius of the quarter circle that is equal to capital R according to our definition. So, therefore, we can conclude from it that the hypotenuse of the green right triangle OCM equals to capital R. It is the radius of the quarter circle. So by finding out the value of the hypotenuse of this right green triangle, we will find out the radius of this quarter circle. That is what we are looking for actually in this question. Okay. Now we will implement the Pythagoras theorem on the right green triangle OMC. So according to the Pythagoras theorem on the right green triangle OMC, so here I write down by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse is OC, therefore the square of the hypotenuse is OC squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM squared plus CM squared. Okay. Repeat again. In the right green triangle OMC, according to the Pythagoras theorem, OC squared must be equal to OM squared plus CM squared. Okay. OC equals to R, therefore OC squared is R squared, and it is equal to OM squared. OM equals to 9 units, therefore OM squared is 9 squared, that is 81, plus CM squared. What is the value of CM? CM equals to CD plus DM. Again, CM equals to CD plus DM, that is to say, CM equals to CD, that is 16, plus DM, that is 8. So in conclusion, in total, CM equals to 16 plus H. So if CM equals to 16 plus H, it means that CM squared will be equal to 16 plus H squared. So according to equation number 1, we found out that R squared equals to 81 plus 16 plus H squared. Okay, so we have here one equation with two variables, that is the radius of the quarter circle that we are looking for, and also H. You cannot solve one equation with two variables. So we must create another equation. In order to create another equation, we join points O and L together by a straight line, and by joining points O and L together by a straight line, actually we created here a triangle OLM. Here actually this is a right triangle, triangle OLM, the green, the orange triangle OLM is a right triangle. Why? Because this angle L and O, or O and L, equals to 90 degrees. Therefore, triangle, the orange triangle, triangle O and L, is a right triangle. Now we will implement the Pythagoras theorem on the right triangle, triangle O and L. Okay, as I've already mentioned before, side ON equals to 9 plus 12, that is 21 units. Okay, so we'll focus on the right triangle, triangle O and L, the orange triangle O and N, or O and L. In the orange right triangle, triangle O and N, by PT is the version for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OL. Here this point is point L. So the hypotenuse is OL, therefore the square of the hypotenuse is OL square. But what is the definition of the hypotenuse OL? O is the center of the quarter circle. L is the point of the quarter circle itself. That is to say, OL is the radius of this quarter circle that is equal to capital R according to our definition. So OL equals to capital R. So OL square equals to LN square plus ON square. I repeat again, according to the Pythagoras theorem, OL square equals to LN square plus ON square. We just right now found out that OL is the radius of the quarter circle that is equal to capital R. So OL square is capital R square, or R square. We have already found out that Ln equals to 21 units. Ln equals to 21 units. So Ln square is 21 square. 21 square is 441 plus, actually it is On square. On equals to 21. Therefore On square equals to 21 square. That is 441. While Ln equals to 8. Therefore Ln square equals to 8 square. Okay, so here Ln square is 8 square and On square is 441. So in conclusion, we found out that according to equation number 2, R square equals to 441 plus 8 square. Okay. While according to equation number 1, we have already found out that R square according to equation number 1, we have already found out that r squared equals to 81 plus 16 plus h squared. We actually have two different expressions for r squared. Now we create equation number 3 that states that r squared according to equation number 1 must be equal to r squared according to equation number 2. So here r squared according to equation number 1 must be equal to r squared according to equation number 2. Okay, so here r squared according to equation number 1 is 81 plus 16 plus h squared, and it must be equal to r squared according to equation number 2, that is 441 plus h squared. Now we actually created equation number 3, consists of one variable only, that is h, and we solve equation number 3 and find out the value of h. Then we will put the value of h in equation number 3, number 2. We will put the value of h that we will find in this equation, equation number 3, equation number 2, and this way we will find out the value of the radius of the quarter circle, the radius that we are looking for. Okay, so we'll solve equation number 3 that has only one variable, that is h. So here we will open the brackets on this side of equation number 3, and we will get that 81 plus 16 plus h squared, 16 plus h squared equals to 16 squared, that is 256, plus h squared, plus 2 times 16 times h is 32h. And it is equal to 441 plus h squared. So here we have h squared on both sides of the equation, so h squared will get cancelled. And in this side of the equation, we have equation number 3, we have 81 plus 256 is 337. Plus 32h equals to 441 equals to 441. So here we subtract from this equation, equation number 3, 337, and you will get that according to equation number 3, 32h equals to 441 minus 337 is 104. So we found out that according to equation number 3, 32h equals to 104. We'll divide this equation, equation number 3, by 32, and we'll get that h equals to 104 over 32 is 3.25 units. So we found out that h equals to 3.25 units. Now we'll put the value of h inside equation number 2. According to equation number 2, r squared equals to 441 plus h squared. So we'll substitute h by 3.25. So r squared equals to 441 plus h squared. H is 3.25, therefore h squared is 3.25 squared, that is 10.5625. Okay, so r squared equals to 441 plus 10.5625 is equal to 451.5625. Here we'll take a root out of this equation and we get that r, the radius that we are looking for in the quarter circle, equals to 21.25 units. Okay, as I already mentioned before, the radius of the quarter circle is a little bit greater than 9 plus 12, that is 21. So it is not 21 but 21.25. So it is a little bit greater than ON, that is equal to 21. Okay, so we finished with the first question. In the next step I present to you the second question, and we'll solve the second question in two different methods. Okay. So in the drawing we have triangle ABC. Side AB equals to x plus y. Side AC equals to y units. Angle ACB equals to 40 degrees. Angle ADC equals to 80 degrees. And we want to find out the size of angle ABC, this angle, that is equal to theta. So we want to find out the size of angle theta. Okay, so in the first method, we'll do a construction. We'll extend side BC in such a way that actually we'll extend side BC in y units. Okay, so here usually CE equals to y according to our construction. We extended side BC in y units, therefore here CE equals to y units according to our construction. In the next step we will join points A and E together by a straight line. So here we created the new triangle ACE. In this new triangle we have those two sides that are equal to each other, so I'll copy the triangle ACE in the new page and we'll analyze the triangle. So this is triangle AC that I copied from the original drawing. In triangle ACE, both side AC and side AC and side CE, they are both equal to y. Therefore, AC equals to AE. They are both equal to y, therefore they are equal to each other. And here we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides there are equal angles. That is to say, those two angles that are located in front of the equal sides, they must be equal to each other. So here angle CAE must be equal to angle AEC. So if we define one angle AEC as alpha, if this angle equals to alpha, then from this equation angle CAE equals to angle AEC equals to alpha, we will derive that angle CAE is also equals to alpha. Okay, so actually we found out that this angle is also equals to alpha. Okay, and in the next step I will present to you the external angle theorem. So what is the external angle theorem? So actually, if we have triangle ABC, that could be any triangle. This is triangle ABC. And here we have, this is angle alpha, this is angle beta, and this is angle gamma. Actually, angles alpha, beta, and gamma, they are all defined as interior angles of triangle ABC. Why? Because they are located inside triangle ABC. They are the interior angles. While this angle, that I will define as angle E is located outside triangle ABC, therefore it is defined as an exterior angle. So angle E is the exterior angle, and according to the exterior angle theorem, the value of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. So this angle E equals to the sum of the two interior angles that are not adjacent to it. Here angle gamma is adjacent to this angle, so the two other interior angles that are not adjacent to it are alpha and beta. So here alpha plus beta equals to the exterior angle E. So the size of the exterior angle E is alpha plus beta. So actually we can implement the exterior angle theorem in our triangle ACE, in order that this angle equals to 40 degrees according to what is given as the question. This angle equals to 40 degrees, angle ACB equals to 40 degrees, as you can see from the drawing. So according to the exterior angle theorem, this angle that is equal to 40 degrees, it is defined as the exterior angle to triangle ACE. So this angle will be equal to the sum of the two interior angles that are not adjacent to it. Those two angles, they are defined as the exterior angles that are not adjacent to it. That is to say, 40 degrees will be equal to alpha plus alpha. According to the angle Bassetto theorem, the this angle that is equal to 40 degrees that is defined as the exterior angle of this triangle ACE must be equal to the sum of the two interior angles that are not adjacent to it. Those two interior angles are not adjacent to this angle that is equal to 40 degrees. Therefore, 40 degrees equals to alpha plus alpha. So we actually found out that 40 degrees equals to alpha plus alpha. According to the exterior angle theorem. Alpha plus alpha is 2 alpha, so 2 alpha equals to 40 degrees. We divide this equation by 2 and we get that alpha equals to 20 degrees. So actually we found out that those two angles that are equal to alpha, they are equal to 20 degrees. Okay. So we'll focus on this triangle ADC. In this triangle ADC, we have two angles that we know the value of them. This angle equals 20 degrees. This angle equals to 40 degrees. 40 degrees plus 80 degrees plus 40 degrees is 120 degrees. So in order to complete the sum of the angles in this triangle ADC to 180 degrees, this angle must be equal to 60 degrees. Because 60 degrees plus 120 degrees is 180 degrees. So this angle must be equal to 60 degrees. In the next step, we will focus on triangle ADE. So I copy triangle ADE in a new page and we'll analyze this triangle ADE. Okay. Angle DAE, this angle equals to 60 degrees plus 20 degrees, it is 80 degrees. This angle equals to 80 degrees. What is the value of line segment DE or side DE? It is very easy to see from the drawing that DE equals to DC plus CE. That is to say, D equals to DC, that is X, plus CE, that is Y. In conclusion, found out that D equals to X plus Y. Here, D equals to X plus Y. So this is triangle ADE that I copied from the original drawing. In this triangle ADE, those two angles are equal to each other, they are both equal to 80 degrees, therefore they are equal to each other. And according to the rule that in front of equal angles in the triangle there are equal sides, so in front of this angle we have side DE. In front of this angle we have side AE. And according to the rule that in front of equal angles in the triangle there are equal sides, we will get that side AE equals to side DE. AE equals to DE, but DE equals to X plus Y. According to what we have already found out, DE equals to X plus Y. And from this equation, X plus Y equals to DE equals to AE, we will derive that side AE is also equals to X plus Y. Side AE is also equals to X plus Y. So this side AE equals to X plus Y. Okay, so we can write here that this side AE equals to X plus Y. Yeah. Actually, this is side AE. here side AE equals to x plus y. So in the next step, I will copy the big triangle ABE in a new page, and we will analyze triangle ABE. So this is triangle ABE. This is triangle ABE, in the copies of the original drawing. We found out that side A equals to x plus y. This is given us the question that side AB equals to also x plus y. Angle ABE, this angle equals to theta. And we already found out that angle AEB equals to 20 degrees. So side AB equals to both sides, side AB and side AE, are equal to x plus y, therefore they are equal to each other. That is to say, side AB equals to side AE. Repeat again, they are both equal to x plus y, therefore they are equal to each other. So we have, in triangle ABE, we have two sides that are equal to each other, and according to the rule that in front of equal sides in the triangle there are equal angles, it means that what this sentence means, it means that in front of this side we have angle theta. In front of this side, side AB, we have angle that is equal to 20 degrees. So in front of those two equal sides, we have equal angles. That is to say, those two angles that are located in front of the equal sides, they must be equal to each other. That is to say, angle theta must be equal to 20 degrees. Why? Because those two angles, theta and 20 degrees, they are located in front of equal sides. Therefore, they are equal between them. That is to say, angle theta equals to 20 degrees. And that is the answer to the question. The angle that we are looking for, angle theta, equals to 20 degrees. We finished with the first method. In the next step, I'll present to you the second method. Here, we focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees. This angle equals to 40 degrees. 40 degrees plus 80 degrees is 120 degrees. So the third angle, this angle, must be equal to 60 degrees. In order to complete the sum of the angles in this triangle, triangle ADC, 280 degrees, this angle must be equal to 60 degrees. Okay, we define side AD as A, and I will present to you the law of sines, and we'll implement the law of sines on both triangles, triangle ADC and triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So if we have this triangle, triangle ABC, that could be any triangle. This is triangle ABC. Side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side AB equals to C units in its length, then according to the law of sines, we get that in this triangle ABC, that could be any triangle, A over sine A equals to B over sine B, and it is equal to C over sine C. Here capital A, capital B, and capital C are the sizes of those three angles. Capital A equals to the size of angle BAC, this angle. Capital B equals to the size of this angle, angle ABC, and capital C equals to the size of this angle, that is angle ACB. And A, B, and C are the lengths of the sides of triangle ABC. So according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. We will implement the law of sines in triangle ADC. This triangle ADC. So in triangle ADC, this is triangle ADC. This is triangle ADC. According to the law of sines, we get that DC over sine 60 degrees equals to AD over sine 40 degrees. AD over sine 40 degrees. And it is equal to AC over sine 80 degrees. AC over sine 80 degrees. Okay. So this is equation number 1. According to equation number 1, DC, here DC equals to x, so we substitute DC by x over sinus 60 degrees equals to AD equals to A, so we substitute AD by A over sinus 40 degrees, and it is equal to AC over sinus 80 degrees. So AC is y, so we substitute AC by y, so it is y over sinus 80 degrees. So those three expressions are equal to each other. So we define the value of those three expressions as k. Those three expressions are equal to each other, therefore we can define their value of k as k. And here we create the first equation. Those two expressions are equal to each other. Here x over sinus 60 degrees equals to k. Repeat again. X over sinus 60 degrees equals to k. here we will multiply this equation number 1 by sinus 60 degrees, and we get that x equals to k times sinus 60 degrees. Okay, x equals to k times sinus 60 degrees. Found out the value of x. Here in the, we also know that those two expressions are equal to each other. That is to say, a over sinus 40 degrees equals to also to k. So I write it down according to equation number 2. A over sinus 40 degrees is equal to k. Here we multiply this equation number 2 by sinus 40 degrees, and we get that according to equation number 2, a equals to sinus 40 degrees times k. So I found out that the value of a is sinus 40 degrees times k. And finally, those two expressions, they are also equal to each other. That is to say, y over sinus 80 degrees equals to k. So I write it down. And into equation number 3, we found out that y over sinus 80 degrees equals to k. Here I multiply this equation number 3 by sinus 80 degrees, and we get that according to equation number 3, y equals to k times sinus 80 degrees. Okay, so we actually found out the values of x, y, and a. In the next step, we will implement the law of sines in this triangle ABD. But before that, we know that here BC is a straight line because it is one side of triangle ABC. BC is a side of a triangle, it must be a straight line. So we can write down that BC is a straight line, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles there must be equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point D? We have here this angle that is equal to 80 degrees plus this angle that is equal to angle ADB. In total, the sum of those two angles that must be equal to 180 degrees. Okay, so here we subtract 80 degrees from this equation, and we get that the missing angle, this angle ADB, equals to 180 degrees minus 80 degrees is 100 degrees. So we found out here that the missing angle ADB equals to 100 degrees. Now we will implement the law of sines in this triangle ADB. So in triangle ADB, according to the law of sines, we will get that in this triangle ADB, x plus y over sinus 100 degrees equals to A over sinus theta. Okay. This equation number 2, is the implementation of the law of sines in triangle ADB. Triangle ADB. Okay, the law of sines. I repeat again. In this triangle ADB, according to the law of sines, we'll get that x plus y over sinus 100 degrees equals to A over sinus theta. Okay. So here we substitute x, y, and A in this equation number 2 by the values that we found for them. According to what we have already found out, we found out that x equals to k times sinus 60 degrees plus y equals to k times sinus 80 degrees over sinus 100 degrees. It is equal to A, and A equals to sinus 40 degrees times K, or K times sinus 40 degrees divided by sinus theta. Okay, so here found out that k times sinus 60 degrees plus k times sinus 80 degrees over sinus 100 degrees equals to k times sinus 40 degrees over sinus theta. Here we cross multiply this equation number 2, and we will get that according to equation, but first of all we divide this equation number 2 by k. So here k will get cancelled, we have k on both sides of the equation, so k will get cancelled, and only then we'll cross multiply this equation number 2, and we get that sinus 60 degrees plus sinus 80 degrees times sinus theta equals to sinus 100 degrees times sinus 40 degrees. Okay, now we will divide this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we will get that the value of theta is actually equals to, according to equation number 2, the value of sinus theta, according to equation number 2, it is equal to sinus 100 degrees times sinus 40 degrees over sinus 80 degrees plus sinus 60 degrees. Okay. We have here a couple of trigonometric identities that we will use in order to simplify the expression here. We know that sinus 90 degrees plus theta equals to cosine theta. Okay. We'll use this trigonometric identity in order to simplify sinus 100 degrees. Sinus 100 degrees is equal to sinus 90 degrees plus 10 degrees, and according to this trigonometric identity, sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. Now we will substitute sinus 100 degrees by cosine 10 degrees, and we'll also simplify sinus 40 degrees by the trigonometric identity that states that sinus 2a equals to 2 times sinus a times cosine a. Okay, here, what is sinus 40 degrees? It is actually equals to 40 degrees is 2 times 20 degrees. So sinus 40 degrees equals to sinus 2 times 20 degrees, and it will be equal, according to this trigonometric identity, to 2 times sinus 20 degrees times cosine 20 degrees. Okay, so now we'll substitute sinus 40 degrees by 2 times sine 20 degrees times cosine 20 degrees, and we'll substitute sinus 100 degrees by cosine 10 degrees. Okay, so we'll do it now, and we'll get that according to the trigonometric identities. Here we'll get that sinus theta equals to sinus 100 degrees, but sinus 100 degrees equals to cosine 10 degrees, so we substitute sinus 100 degrees by cosine 10 degrees times sinus 40 degrees. And we already found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. All divided by sinus 80 degrees plus sinus 60 degrees. Okay. In the denominator, we have sinus 60 degrees plus sinus 80 degrees plus sinus 60 degrees. So we'll simplify this expression by the trigonometric identity that states that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. Okay, so use this trigonometric identity in order to simplify sinus 80 degrees plus sinus 60 degrees. So here we will get that sinus 80 degrees plus sinus 60 degrees, it is equal, according to this trigonometric identity, it is equal to 2 times sinus d plus c over 2 is 80 plus 60 over 2. 80 plus 60 is 140, and 140 over 2 is 70. So it's 70 degrees times cosine d minus c. D is 80 and c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 60 degrees plus sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees by cosine 10 degrees. Now we substitute sinus 60 degrees plus sinus 60 degrees by 2 sine 70 degrees times cosine 10 degrees. So we'll do it now, and we get that according to equation number 2, sinus theta equals to 2 times cosine 10 degrees times sinus 20 degrees times cosine 20 degrees. all divided by sinus 80 degrees plus 60 degrees, but we already found out that according to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator. So cosine 10 degrees will get cancelled. And we have 2 in the numerator and 2 in the denominator. So 2 will also get cancelled. And what is left from the equation number 2 after we cancelled the two expressions here? What is left is actually we have here sinus theta that is equal to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Okay, now we'll use the third trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta. According to this trigonometric identity, we will get that the value of sinus 70 degrees equals to sinus 70 degrees. It is equal to sinus 90 degrees minus 20 degrees, and according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we will get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. In conclusion, we found out that sinus 70 degrees is equal to cosine 20 degrees. So we'll substitute sinus 70 degrees in equation number 2 by cosine 20 degrees. And we'll get that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, and we just right now found out that sinus 70 degrees equals to cosine 20 degrees, so we substitute sinus 70 degrees by cosine 20 degrees. So here we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and you're left only with, according to equation number 2, we found out that sinus theta equals to sinus 20 degrees. If sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees, and that is the answer to the question. That theta equals to 20 degrees. So we finished with the second method. In the next step, I'll summarize the lecture. We'll start with the first question, of course. In the drawing, we have a quarter circle. We know that side AC equals to 9 units, side CD equals to 16 units, side DL equals to 12 units. Angle OBC equals to 90 degrees. This angle BCD equals to 90 degrees, and this angle CDL also equals to 90 degrees. and our mission is to find out the radius of this quarter circle. So first of all, because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. This angle BON equals to 90 degrees, and sides AO and OF, they are both the radii of this quarter circle, that is equal to capital R according to our definition. Okay, so in the next step, I extended the straight line CD by a straight line until it touches the radius OF at point M. Point M is the touching point between the extended CD and the radius OF. Okay, so here, by doing this construction, we actually created here quadrilateral BCOM, and inside quadrilateral BCOM we have 1, 2, 3 right angles. So I repeat again, inside quadrilateral BCOM we have 1, 2, 3 right angles. Okay, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, this is actually angle DMO, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we subtract the 270 degrees from this equation, and we found out that the missing angle DMO is equal to 90 degrees. So this angle is a right angle, it is equal to 90 degrees. So actually we found out that inside this quadrilateral BCOM we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to this quadrilateral BCOM as a rectangle because of the fact that it has 4 right angles. So quadrilateral BCOM is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, here in rectangle BCOM, side BC equals to side OM. Side BC equals to side OM, according to the rule that the opposite sides of a rectangle are equal to each other. But according to what is given as the equation, side BC equals to 9 units. So side BC equals to 9 units. So we can write here that BC equals to 9, and from this equation 9 equals to BC equals to OM, we will derive that side OM is also equals to 9 units. Here, side OM is also equals to 9 units. Okay? Then, here, OF is the radius of the quarter circle, therefore it is absolutely a straight line. OF is the radius of the quarter circle, it is absolutely a straight line. And we have the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Okay. Therefore, according to rule number 3, that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Here alpha plus beta equals to 180 degrees. We can implement this rule in our drawing. Here we have the straight line OF. If we focus on the upper side of the straight line OF at point M, then the sum of the angles here must be equal to 180 degrees according to the rule that I mentioned. So which angles we have here? We have this angle that is equal to 90 degrees plus angle DMF. In total, the sum of those 2 angles must be equal to 180 degrees. So here, angle 90 degrees plus the size of angle DMF, that must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that the missing angle DMF, this angle DMF equals to 90 degrees. Okay, likewise, we know that CD is a straight line, it is equal to 60 degrees, it is a straight line according to what is given as the question. And when you extended the straight line CD by a straight line, the result, that is CM, must be a straight line. Okay, so the result of the extension of CD by a straight line, that is CM, must be a straight line. So CM is a straight line. So we know that CM is a straight line, and according to the rule that the sum of the angles on one side of the straight line equals to 180 degrees, we will get that if we focus on this side of the straight line CM at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at this side of the straight line CM at point D? We have here 90 degrees plus angle MDL. In total, the sum of those two angles must be equal to 180 degrees. Repeat again. Here, angle 90 degrees plus angle LDM, in total they must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle LDM equals to 90 degrees. So this angle also equals to 90 degrees. So in conclusion, we found out that those two angles, they are both equal to 90 degrees. Then we did the construction from point L. We drew perpendicular on the radius OF. I repeat again, from point L, we drew perpendicular on the radius OF. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point L and OF as point M. It's point N. So this angle equals to 90 degrees according to our construction. So by this construction, we get the quadrilateral DLMN that has 1, 2, 3 right angles. Inside this quadrilateral LDMN, we have 1, 2, 3 right angles. And we know that the sum of 3 right angles is 90 times 3 is 270 degrees. 270 degrees plus the size of the fourth angle, that is actually angle DLN. This angle, DLN, in total the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and we get that the missing angle DLN equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So the fourth angle, it is a right angle. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a right angle if not a square. So quadrilateral DLMN that has 4 right angles must be, so we relate to quadrilateral DLMN that has 4 right angles as a rectangle. So quadrilateral DLMN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So here, in rectangle DLMN, side DL must be equal to side MN. Side DL must be equal to side MN according to the rule that the opposite sides of a rectangle are equal to each other. But according to what is given as the equation, side DL equals to 12 units. So here we can write down that DL equals to 12 units, and from this equation 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Side MN equals to 12 units. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that side DM equals to side LN. Side DM equals to side LN. According to the same rule that the opposite sides of a rectangle are equal to each other. Here we define side DM as edge. Here side DM equals to edge according to our definition. So here we can write down that DM equals to edge according to our definition. So from this equation x equals to DM equals to ln, we derive that ln is also equals to edge. Here ln is also equals to edge. Okay? In the next step, we join points O and C together by straight line. By joining points O and C by straight line, we created here the green right triangle OCM. We implemented the Pythagoras theorem on this right triangle OCM. What is the definition of the hypotenuse OC of the right triangle OMC? Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. Therefore, OM is the radius of this quarter circle that is equal to capital R according to our definition. So OC equals to capital R. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So the green right triangle OCM, OC square must be equal to OM square plus CM square. In right triangle OCM, according to the Pythagoras theorem, OC square equals to OM square plus CM square. OC equals to R, it is the radius of the circle, so OC square is R square. OM equals to 9 units, therefore OM square is 9 squared, that is 81, plus CM square. What is the value of CM? From the drawing, it is very easy to see that CM equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is H. So in total, CM equals to 16 plus H. So CM equals to 16 plus H, therefore CM square equals to 16 plus H square. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 60 plus H square. Okay? Then, so this is the first equation that we derived from this right triangle, triangle OCM. Then we joined points O and L together by a straight line, and this way we created the right triangle, the right orange triangle, triangle OLN. And we implemented the Pythagoras theorem of the right orange triangle, triangle OLN. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. What is the definition of the hypotenuse OL of the right triangle ONL? Point O is the center of the quarter circle, point L is the point of the quarter circle itself, therefore OL is the radius of this quarter circle, that is equal to capital R. So OL equals to capital R. So here, according to the Pythagoras theorem, OL square equals to ON square plus LN square. OL square equals to LN square plus ON square. ON equals to R, so OL square is R square. LN, here LN equals to H. It is actually LN equals to H, therefore LN square equals to H square. And here ON equals to 9 plus 12, that is 21. So LN equals to 21, therefore LN square is 21 square. Here ON square is 21 square, and ON square is 21 square, and 21 square is 441. So in conclusion, we found out that according to equation number 2, R square equals to 441 plus H square. So here we have two different expressions for R square. Therefore, we created equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 equals to 81 plus 16 plus H square, and it must be equal to R square according to equation number 2, that is equal to 441 plus H square. Here we open the brackets on this side of equation number 3, and we found out that 81 plus 16 plus H square equals to 16 square, that is 256, plus H square, plus 2 times 16 times H is 32H, and it is equal to 441 plus H square. Here we have H square on both sides of the equation, so H square will get cancelled. And in this side of the equation we have 81 plus 256 is 337 plus 32H. It is in this side of the equation, and the other side of the equation we have 441. Here we subtracted 337 from this equation, equation number 3, and we found out that according to equation number 3, 32H equals to 441 minus 337 equals to 104. So here 32H equals to 104. Here we divided this equation, equation number 3, by 32, and we found out that H equals to 3.25 units. H equals to 3.25 units. Then we put the value of H inside the equation number 2. Here, according to equation number 2, we only found out that R square equals to 441 plus H square. So we substituted H by 3.25. If H equals to 3.25, then H square will be equal to 3.25 square, and 3.25 square equals to 10.56, So in conclusion, we found out that R square that is equal to 441 plus H square equals to actually to 441 plus 10.56 to 5. 441 plus 10.56 to 5 equals to 451.56 to 5. We took out of this equation and found out that the radius of this quarter circle it is equal to 21.25 units. As already mentioned, the radius of this quarter circle it is a little bit greater than the length of ON, that is 21. It is equal to 21.25 units. We finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. So here we have triangle ABC, side AB equals to x plus y, side DC equals to x, this angle equals to 60 degrees, and our mission is to find out the value of this angle theta. So first of all, we did the construction. We extended side DC in y units. That is to say, CE equals to y units according to our construction. Then we joined points A and D together by a straight line. In this way, we created triangle AC. And so I copied triangle AC in a new page, and we analyzed this triangle AC. In triangle AC, those two sides are both equal to y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two sides that are located in front of those two angles must be equal to each other because they are located in front of equal sides. So if one angle is alpha, then the other angle must be also equal to alpha. So I already mentioned AC equals to A equals to Y. Therefore, angle CAE equals to angle AC equals to alpha. So if one angle equals to alpha, then the other angle also equals to alpha. Then I mentioned the external angle theorem. According to external angle theorem, here we have triangle ABC that could be any triangle. In triangle ABC, angles alpha, beta, and gamma are defined as interior angles because they are located inside triangle ABC, while this angle E is defined as exterior angle, while it is because of the fact that it is located outside triangle ABC. And what is the value of the exterior angle E? It is equal to the sum of the angles, the sum of the two angles, the sum of the two interior angles that are not adjacent to it. Angle gamma is adjacent to it, and the two other angles that are not adjacent to it is alpha plus beta. That is to say, the value of the exterior angle E is equal to alpha plus beta. So we can implement all the exterior angle theorem in triangle ACE. In triangle ACE, the exterior angle is 40 degrees, and the exterior angle that is 40 degrees, it must be equal to alpha plus alpha. So 40 degrees equals to alpha plus alpha. So if 40 degrees equals to alpha plus alpha, it means we divided, so 2 alpha equals to 40 degrees, we divided this equation by 2 and found out that alpha equals to 20 degrees. So here, this angle equals to 20 degrees, and this angle also equals to 20 degrees. Then I copied triangle ADE in a new, this page, and this angle DAE equals to 60 degrees plus 20 degrees. Here, this angle DAE equals to 80 degrees. This angle also equals to 80 degrees according to what is given as the question. So those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle there are equal sides. So this angle is located in front of side DE, this angle is located in front of side AE, therefore those two sides must be equal to each other because they are located in front of equal angles. So side AE equals to side DE. But we know that the value of side DE is x plus y. So DE equals to x plus y, and from this equation DE equals to x plus y equals to DE equals to AE, we will derive that side AE is also equals to x plus y. Here side AE is also equals to x plus y, so I copied I copied triangle AEB, the big triangle AEB in this page, And we just right now found out that side A equals to x plus y, side AB equals to x plus y according to what is given as the question. This angle is theta is the angle that we are looking for, and we have already found out that this angle equals to 90 degrees. So those two sides, they are both equal to x plus y. Therefore, they are equal to each other. Here, side AB equals to side AE. Those two sides are equal to x plus y, therefore they are equal to each other. That is to say, side AB equals to side AE. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, there are equal angles. That is to say, those two angles that are located in front of equal sides must be equal to each other. That is to say, angle theta must be equal to 20 degrees. So in conclusion, we found out that angle theta equals to 20 degrees. Then I presented to you the second method. In the second method, I repeat again that our mission was to find out the size of this angle, angle theta. So here we focused on triangle ADC. In triangle ADC, this angle equals to 80 degrees. This angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So the missing angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle, triangle ADC to 180 degrees. This angle must be equal to 60 degrees. Then we defined angle AD as A. And then I presented to you the law of sines, and we implemented the law of sines on triangle ADC and triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So here we have triangle ABC that could be any triangle. Side AB equals to C units, side BC equals to A units in length, and side AC equals to B units in length. Then according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. Here capital A and capital B and capital C are the, here this is the value of the size of this angle is capital A, the size of this angle is capital B, and the size of this angle is capital C. And A, B, and C are the lengths of the sides of the triangle ABC. So we implemented the law of sines in this triangle, triangle ADC. In triangle ADC, according to, but before we implemented actually, we found out that this angle equals to 180 degrees, according to 100 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 100 degrees. So if this angle equals to 80 degrees, this angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of the straight line BC to 180 degrees. This angle must be equal to 100 degrees. So we implemented the law of sines in this triangle, triangle ADC. According to the law of sines, we'll get that DC over sine 60 degrees equals to AD over sine 40 degrees, and it is equal to AC over sine 80 degrees. DC equals to X, so we substitute DC by X. AD equals to Y, we substitute AD equals to A, therefore we substitute AD by A, and AC equals to Y, so we substitute AC by Y. So in conclusion, we found out that X over sine 60 degrees equals to A over sine 40 degrees, that is equal to Y over sine 80 degrees. So because of the fact that those three expressions are equal to each other, we can define them as K. So they are equal to K. From this big equation, we derived three different equations. Here, those two, X over sine 60 degrees equals to K. This is the first equation. Then we multiplied this equation by sine 60 degrees and found out that X equals to K times sine 60 degrees. Then those two expressions are also equal to each other. That is to say, A over sine 40 degrees equals to K. Here we multiplied this equation number 2 by sinus 40 degrees, and found out that A equals to sinus 40 degrees times K. And then finally, those two expressions are also equal to each other. So Y over sinus 80 degrees equals to K. We multiplied this equation by sinus 80 degrees and found out that according to equation number 3, y equals to k times sinus 80 degrees. So we actually found out the values of x, y, and a. Then here, as I already mentioned here, BC is one side of triangle ABC, therefore it is a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point D, the upper side of BC? We have here 80 degrees plus this angle ADB. 80 degrees plus angle ADB must be equal to 180 degrees. We subtracted 80 degrees from this equation and found out that the missing angle ADB equals to 100 degrees. So this angle equals to 100 degrees. Then we focused on this triangle ADB, and we implemented the law of sines in this triangle ADB. According to the law of sines in this triangle ADB, we will get that x plus y over sinus 100 degrees equals to a over sinus theta. I repeat again, x plus y over sinus 100 degrees equals to a over sinus theta according to the law of sines. Now we substitute x by k times sinus 60 degrees, we substitute y by k times sinus 80 degrees, and we substitute a by k times sinus 40 degrees, and we got this expression. And then we have k on both sides of the equation number 2, so k will get cancelled. Then because multiply this equation number 2, and we got to this equation. Then we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we found out that sinus theta equals to sinus 100 degrees plus sinus 40 degrees over sinus 80 degrees plus sinus 60 degrees. Okay. Then we have the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta. So according to this trigonometric identity, we will get that sinus 100 degrees that is equal to sinus 90 degrees plus theta equals to sinus 90 degrees plus 10 degrees. It is equal to cosine 10 degrees. According to this trigonometric identity, it is equal to cosine 10 degrees. And we have also the trigonometric identity that sinus 2a equals to 2 sine a cosine a. Sinus 40 degrees is sinus 2 times 20 degrees, and according to this trigonometric identity, it will be equal to 2 times sinus 20 degrees times cosine 20 degrees. Therefore, here we got that sinus theta equals to, we substituted cosine theta by cosine 10 degrees, and we substituted sinus 40 degrees by sinus 20 degrees times cosine 20 degrees times 2 over sinus 80 degrees plus sinus 60 degrees. Then, in order to simplify the expression of sinus 80 degrees plus sinus 60 degrees, we use the trigonometric identity that states that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. According to this trigonometric identity, we will get that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d plus c is 80 plus 60, that is 140, and 140 over 2 is 70 degrees, times cosine d minus c is 80 minus 60, that is 20, and 20 over 2 is 10, so it is cosine 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Then, so we can substitute the denominator by 2 times sinus 70 degrees times cosine 10 degrees. We did it, and we got that sinus theta equals to cosine 10 degrees times sinus 20 degrees times cosine 20 degrees, and instead of sine 80 degrees plus sine 60 degrees, we wrote down 2 sine 70 degrees times cosine 10 degrees according to this trigonometric identity, of course. We have cosine 10 degrees on both sides of the equation, so cosine 10 degrees will get cancelled. We have 2 on both sides of the, we have cosine 10 degrees, both the numerator and the denominator, so cosine 10 degrees will get cancelled. We have 2, both the numerator and the denominator, so 2 will get cancelled. And we're left only with sine theta, that is equal to sine 20 degrees times cosine 20 degrees over sinus 70 degrees. We use the trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta. According to this trigonometric identity, we get that sinus 70 degrees equals to sinus, that is equal to sinus 90 degrees minus 20 degrees. It is equal to cosine 20 degrees. Why? Because sinus 90 degrees minus theta equals to cosine theta, that is to say sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees by cosine 20 degrees. We did it, and we got that sinus theta equals to sine 20 degrees times cosine 20 degrees, and we substituted cosine 70 degrees by cosine 20 degrees. Therefore, we have here cosine 20 degrees in the numerator, and we have cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we left only with sine theta, that is equal to sine 20 degrees. If sine theta equals to sine 20 degrees, it means that theta equals to 20 degrees. So actually we found out in both methods that the size of this angle theta, it is equal to 20 degrees. Okay? Thank you very much.